In this session, I am going to explain deletion, search, and display operations of double linked list. Now, explain what is searching. Searching is nothing but finding an element which we want. That means any element we required that should be in a linked list. If it is there, it will find out and gives the element is there or found. Otherwise, it will give no elements was found. Searching is a double linked list is one of the common operation. The list traversed from the beginning and checked if the given element is present in the list. That means the elements always beginning at the beginning of the linked list, and it will go on finding the elements which is required. Or now I am going to explain the code for searching an elements. These two are common. That is, I am writing a header file. Then I am declaring a node. That means here the node consists of three types. One is previous. Then in middle it is element. Next is the address of the next node, and previous is the address of the previous node. In center it will stores the elements. And here I am declaring two nodes. One is head and another one is last. This head is used at the beginning and last is used at the last at or end of the node or rear of the node. That means to identify whether the linked list is ended or not. Now I am taking three functions here. One is for creating and another one is for displaying an elements, and last one is searching an elements. This display is used two times. One is for after creating a list and after searching an elements. Now I have begin with the main function. I have declared a variables n and data. Now initially I have initialized head with a null value and last with a null. This means these two are I have taken as an a node. Now I am requesting an a how many nodes to be created. Then I have scanned that how much required. For example, it may be 3 or 10. Then I am calling a this create function, and this is function is called here. And next I am taking the double linked list. I am displaying this. That means after working this function, that means create list means if I take 10 nodes, after creating a 10 nodes, I want to see how it is created. For that reason I am going to display the list. After that I am entering elements to be searched, and I am scanning that data, and I am searching an element in data. This function is also predefined here. You can see here same function is called here. If the element is found, it will display element is found. Otherwise element is not found. And then after that I am returning a 0 and I am closing a main function. This one is previously I have explained how it is created. Once again also with a brief I am going to explain how it will be created. I am calling a function create list in 10. Then I am taking a two variables I and data. I am declaring a new node. Then I am initially calling I am calling a malloc for allocating a size to the head node. Then I am printing node 1. I am taking the data, and for head I am initializing the data head previous, that is also will be null, and head next, that will be also null. Initially there is only one node. For that reason previous is will be also null and next will be also null. Then I am initializing last equals to head. Then I am entering into a loop I equals to 2 because one node is I have created here. Next node should be started with second node. For that reason I am taking I equals to 2. Then I is less than or equal to n nodes. Then I am going to increment. That means I am initializing here n nodes. For creating n nodes we need a memory. For that reason I am taking a dynamic memory, that is malloc, and new node is created. After creating we are entering a data. Once again new node equals to data, new node previous equals to last, that is link new node with the previous node, and new node next equals to null, that means last of next equals to new node. Here what happens, link will be previous node with the new node, then last equals to new node, make a new node as the last node. Here we can see the display function. If head equals to null, list is empty, that means nothing is there. Otherwise, if a head is not equal to null, for that reason I am taking another variable temp and I am initializing it is an head. If it is not null, it will print the data which are in temp until where n elements is there. For that reason I am moving the current pointer to the next. For that reason we are taking temp equals to temp of next. This is how the display function will work. Now I am concentrating on how search elements will be done. Here you can see struct node, temp of struct node, malloc size of struct node. That means I am creating a new node as a temporary, and I am initializing memory to that one. For temp initially I am assigning it is an head, then initial position will be 0. For that reason I am calling a variable int position equals to 0. When the temporary is not null, then temp of data equals to data element is found. Then it will print the message the data and the position where the element. If it is not equals to data, then it will move to the temp of next, and it will travels the list, and it will go on incrementing the position. If the element is found, here you can see it will display here. If it is not found, it will print it is not found. Here the element is not found in the list data. This is how the searching and displaying and previously how created. Now I am going to concentrate on deletion. In double linked list, the deletion operation can be performed in three ways as follows. One is deleting from beginning of the list, and deleting from end of the list, and deleting a specific node. This is same thing can be done in inserting. Here also inserting can be done from beginning of the list, inserting can be done at the end of the list, and inserting can be done at specific node. Previously we have explained all these things. Now I am concentrating on deleting. First I will take this one, deleting from beginning of the list. Deleting from the beginning of the list. Here you can follow the step how it can be done. That means algorithms. First I will check whether it is empty or not. That means for that reason I am taking head equals to null. If the first, what is the head? Head is nothing but the first node of the linked list. If it is null, then it will print empty is a it will print as empty. In second step, if it is empty, then display list is empty, deletion is not possible, and terminate the function. Because when it is empty, there is no elements. We cannot delete the elements. Next step, what happens? If it is not empty, then define a node pointer temp and initialize with the head. This temp here we have taken to has a head because we cannot move head from one node to the another node. What happens if you move? We cannot count actually where it is there. For that reason, I am taking another variable and naming head as an temp. See here we are showing check whether list is having only one node. For that reason, temp equals to previous and is equal to temp of next. If the condition is true, then what happens? Head will set to the null and delete temp and setting empty list conditions. If this condition is false, then what happens? Temp is tends to next to head and null to head and previous and delete temp. Then deleting from end of the list, that is uh, previous. Now here end. What are the steps we will follow? We will check whether the list is empty. First we'll check for that. Previously also same condition is there. Here is also same condition. That means if head equals to null, then it will print. If it is empty, then display list is empty and deletion is not possible and terminate the function. Next step is what? If it is not empty, then temp and initialize with the head, same what we have done in previous. Then check whether the list has only one node. Temp previous and temp of next both are null. That means temp of and temp of next equals to null. Then if the condition is true, then if condition is true, then it will assign null to head and delete the temp and terminate from the function. If it is false, then keep moving temp until it reaches to the last node. For that reason, we will take temp of next is equal to null. When it is equal to null, what happen? It will assign null to the temp of previous and temp of next and delete the temp. Then now this is deleting an element at the specific node. That means here previously we have checked, here check is there and here is null is there. Now in previous slides we have deleting at front end and deleting at rear end. Now I want to delete a list node. Then what are the steps we should be followed? See, in all deleting, these two conditions are same. Only after fourth step little bit conditions will be changed, because when the head null is a head, that means first is null, it is always empty. See, step 1, check whether list is empty, head equals to null. If it is null, then display list is empty and deletion is not possible and terminate the functions. If it is empty, then define node pointer temp and initialize with the head. Then keep on moving the temp. Then temp, that is temp of next. Keep moving the temp until it reaches to exact node to be deleted or to the last node. Last node means here what happens? Null. That is temp of next equals to null. Here if it reaches to the last node, then display given node not found in the list and deletion is not possible, because there is no specific element or specific node is given to delete and it will terminate the function. If it reaches to the exact node which we want to be deleted, then check whether list is having only one node or not. If it is has only one node and that is the node which is to be deleted, then set head to null and delete temp and free temp. This is an once again dynamic function. This function is used to delete an dynamic memory which is allocated. Here which memory is allocated? Here we have used malloc to allocate a memory. Next, step 8. What happens if list contains multiple nodes? Then check whether temp is first node in the list. For that we are taking temp equals to head. If temp is the first node, then move the head to the next node. For that reason, we are taking head equals to head of next, and I am setting head to the previous as a null. That means head of previous equals to null and delete the temp. Now that means here what happens when we set this, the link will be disconnected from the temp and we are free to delete. Then if temp is not the first node, then check whether it is the last node in the list. For that reason, we are moving. Last node means I have told many times the last node will always contains the null value. That means temp of next equals to null. Next, if temp is the last node, then set temp of previous of next to null. That is temp of previous, and then equals to temp of next equals to null, and delete temp and free the temp. If temp is not the first node and not the last node, then set up temp of previous to next to temp of next. That means here you can see temp of previous, then next equals to temp of next, then temp of next of previous to temp of previous. That means temp of next then equals to previous equals to temp of previous, and then we can delete the temp. That is temp free of temp. Here you can see the displaying how it is done. First we'll check whether there is any elements or not. For that reason list is empty. That is head equals to null. If it is empty, then display list is empty and terminate the function. If it is not empty, then define node pointer temp and initialize with the head, because we will begin always from the head of the linked list and display as null. Then keep displaying temp data with an arrow until temp reaches to the last node. Last node means what here? Null. See, you can see here. That is in sixth step. Finally, display temp of data with arrow pointing to null. That is temp of data, then the temp of equals to temp of null. Then it is end of node. Thank you.